But as we go along, though, they get worse and worse. So we're going to see what I mean by that here. FL is the fraction of those planets where life exists. Now, this is the problem here. And this right here, it's often written as F life. So the fraction with life. We don't know this. We only have one data point. It's hard to know about something or do statistics if you only have one data point. We only know one place in the universe where there's life. It's only the Earth. So it's hard to know what fraction of habitable planets are habited. See, the fact that a planet lies within the habitable zone doesn't mean there's necessarily life there, right? So maybe not all the ones that lie in the habitable zone are habited or inhabited. So in this case, that's the sort of main thing to look at here. So when we look at this then, what fraction of those has life? This is hard to tell. I mean, if we said that FL, let's say, was 1, that would mean that all habitable planets would have life. And if we said that if FL was, let's say we said it was 1 in 1,000, well, that would mean that only one planet out of 1,000 habitable planets have life on them. So what number should we use here? We don't really know. This is a really tough one. This is, we're getting worse and worse here with how much we know. But I've seen a number of people actually use this number. So it's been estimated for different reasons to be this. Now this is super dodgy, okay? So this one right here, I'm going to put a big question mark by it. We're really not sure. This might absolutely be different. Now Fi is the fraction of those worlds, so we're sort of going, the ones that have life. Now the ones that do have life, how many of those have intelligent life? Because that's a whole different story. Having life, this might be little bacteria or little creepy crawly things. Which of those are intelligent? In other words, which of those actually might, be able to communicate in theory? So not necessarily this, we're just saying intelligent. Intelligent enough to, in theory, communicate with us. So there has to be intelligence here. So Fi. Often Fi is called F intelligence. So that's sort of often what its nickname is, so F intelligence. And again, we have no idea what this right here. This is a complete guess here, but let's assume that half of those planets have intelligent life. This is again a super guess, so it gets sort of worse here. We don't know. But if we assume it's half, there we go. And finally, FC, that is the fraction of those that send detectable signals. In other words, they have a civilization. So oftentimes this is called FCiv for civilization. And again, now here, we're using radio signals or, whatever signals that are detectable that they're sending out. We're using that as a proxy for intelligence. I mean, we're trying to say that, if they can send them out, they must be smart. And these are obviously the people we want to talk to because they're the ones talking. If you're a little, worm or some weird, animal on a distant planet, maybe you don't care to send out a signal, and that's fine. We just won't be able to talk to them yet unless we go there and see them. But we're considering here the fraction of those, intelligent life forms that are going to send detectable signals. So we call it FCiv. And again, no idea here. So let's just assume that it is 50% again. So we'll say, all right, let's just say that 50%, so 0.5 here, that's what 50% is. Let's say that 0.5 is FC here. But again, even worse. We have no idea here. Then L is the lifetime of civilization. That's because if they're capable of sending signals, how long until they kill each other off, maybe? This was exceptionally important, especially during the Cold War when this right here was actually devised. Because a lot of scientists were talking about, we're about to be at war with the Russians and maybe we're all going to kill ourselves off and maybe there won't be any humans left because we're going to use atomic weapons and everyone's going to die. So the lifetime of a civilization became something really important. And it turns out this may be the most important one. Turns out the lifetime is, this equation is very sensitive to this. Well, it's sensitive to all the other ones too, but the lifetime is one that can vary immensely. So a lifetime of a civilization, let's just assume that the lifetime is 420 years. I've seen that quoted a few times for different reasons. Let's just assume that that was the case. Now, if that's the case, then we can actually start to calculate this. So let's actually go through this equation and put all the numbers in. So let's do it right now. So I'll just put maybe a little line here. We'll calculate n. So we said n is equal to r star. Now we talked about that. I mentioned it here. Let's say that r is 7. All right, so I need a 7 here. Times, so actually I'll write it like this. I'll put a little x there. A lot of people like to see it like that. So I'll say 7 times Fp. Now what's the fraction that have planets? Let's see here. That would be, so here we have Fp, which is 1, and Ne, which is 2. So I'll go back and write those out. Okay, so we have Fp and Ne, so that's going to be 1 and 2. So let me just go back to my screen here. There we go. So we're going to say times 1 times 2. And then we said that the fraction that will actually have life on them, we said that was going to be 0.13. And we said that the fraction that would have intelligent life, these are all 0.5. So Fi was 0.5, Fc was 0.5, and then we said here that this here is 420. So let's try to actually calculate this here. So that means that n equals, I've just got to multiply these numbers together. So luckily I've got my trusty calculator here. I'm just going to move it out of the way so we can see. So 7 times 1, well 7 times 1 does nothing, times 2 times 0.13 times 0.5. See, this is easy to do. Times 0.5 times 420. And this would tell me that there would be roughly this many. Okay, so this here would be there'd be roughly this many here. So this right here is 191. So we could say that n would be roughly 191 civilizations that we could actually talk to. This is the number of alien civilizations we can actually, discuss things with, perhaps, or at least detect their signals. Now you can be totally optimistic with these, or you can totally be pessimistic. So you could completely change these numbers, and in fact, I welcome you to try these out. You can even find online a Drake equation calculator that does it for you. You basically just put in your values. There's different versions of this equation, but I think this is a really nice way to at least start the discussion of these things. So this doesn't necessarily help us that much, saying there's 191 alien beings we could be able to talk to using these numbers. But what it does tell us is these are the things that are important. So at least it sort of gives us a shopping list of variables we need to find out about. Although we know the rate of star formation, we know what fraction have planets, at least we're getting better here. The fraction of those that are habitable, we have an idea about those. But then what fraction of those have life? Well, we'd have to detect life there, so these get worse. What fraction of life is intelligent? We don't know. What fraction of those have a civilization? Really don't know. How long do civilizations live? We really don't know. But as we learn more about ourselves, these ones right here become really important. And you might even try doing something really crazy. Like, who's to say that a civilization lasts 400 years? What if a civilization lasts, I don't know, what if it lasts 1 billion years? This is 1 million, so I need 1 billion because that's 9 zeros. Try putting that into this equation to see how much it changes it. It changes it immensely. So this right here, it's very sensitive to L here. So you could say that, changing your values of L have a big effect on it. Well, all the other ones do too, because if you make one of them 0, then there's 0 of these. I suppose that's also very sensitive, right? If you make any of these fractions 0, the whole thing becomes 0. But you can try different things with what you think. What if you estimated there was a different value of one of these? Try it out yourselves and see what you get. See if we're really optimistic or not. But at least what it does, though, it tells us sort of what we need to find out. And we can find out a lot about ourselves by thinking about this equation.